Hello, my name is Ethan.
And my name is Grant.
And we have designed a system that will go on a bike. The system is essentially a computer chip that will control some lights and a display. What the system does is it gives the user control of turn signals and a brake light. The display will be used to show when the brake light is on and when the turn signals are on and which one is actually on. And it will also tell the user how fast they're going.
The problem we were trying to solve was that cyclist deaths are on the rise. According to the National Safety Council, cyclist deaths were up about 2% in 2023 and up 37% over the last 10 years. Bike lanes are not a high priority for cities, and it comes at the expense of increased cyclist death. This system, our system, is designed to make cyclists more visible on the road and allows them to more seamlessly communicate with cars and other cyclists.
I will now show you how the user interacts with the bike. You can see on the handlebars two colored buttons, and these the user can press and they'll turn on the corresponding turn signals on either end of the handlebars. For example, if you hit the right turning signal on the handlebar, it'll turn the right turn signal on. The user can also interact with the system with the two buttons on the brake handles. If these buttons are depressed, as such the user is using the brakes, then the brake light should turn on. The system will have a display, and this display is going to show the speed the user is traveling at, if the turn signal is on and which one is on, and if the brake is on or off. We also have a sensor taped to the wheel, and this sensor is going to keep track of how many rotations the wheel makes and thus how fast the bike is traveling.
Now we want to show you the internals of our system. So as you can see here on the right side, we needed 6 wires to hook up these two buttons and this light. All these wires are actually routed through the handlebars, which are hollow, down through the handlebars, through this hole here, and into this box, which contains all of our components to make the system run. You can see the same on the other side. We needed 6 wires routed through the handlebars, although you can't see the wires for the light and for this button. You can also see the wires for the brake light LED are routed along here and into the back of the box, and the wires for our sensor are wired up from the wheel and into the box. Taking a peek inside, if I can get it open, you will see a mess of wires, but underneath that is the battery pack that's running the system, the computer chip, this board called the Nucleo board, and this piece of circuit board that has all of our circuit connections. In this section, we want to give you a demonstration of our system's capabilities. So if you come and see, this is the left turn signal button. When I press it, the left turn signal will blink. If this remains on and we press the right turn signal, the left will turn off and the right will turn on. If we press the right again, the right signal will turn off. If we press either of the brake buttons, the brake light will turn on. As you can see, the brake is displayed when it's on, when I'm pressing the button, and the turn signal is also displayed when I press the button. For example, the left turn signal would display left.
I'm now going to show you how the speedometer on our bike works. If you look at the display, you'll see the speed reading. I will now walk the bike and show you that it should increase. I will also stop the bike and show you that it returns to 0. As you can see, the speed had increased, and we'll wait now for it to return to 0. As you can see, it returned to 0 because the bike is not moving anymore.